We got the microphone now, and we're live. I think the microphone is going. So hopefully somebody will give me a thumbs up. I don't have anybody in the chat right now, so I have no idea if anybody is out there listening. So, again, my name is Tim Van Milligan. This is RockSim Live, where we talk about RockSim, the RockSim Pro, and the Launch Visualizer, because they're all kind of one big happy product family. If you have something to say, go ahead and put it in the comments. We're looking for questions about how to use the software. And this is your chance to make those questions heard so I can answer them right here, right now, live. Otherwise, you'll be watching this on replay and it's not live then. So, let me show you my screen and let's go through a little bit of introductions here. Oh, there's my screen. Our web address is apogeerockets.com. It's up here at the top. When you get to our page, this is kind of what it looks like. This banner bar here, if you scroll through it, here is the launch visualizer. It's at rocksim.com. We have a gliding parachute, and then here's RockSim, and if you click on this, it'll take you to some information about RockSim where you can download a free trial version right here. If you're back on the home page, and if you scroll down a bit, right here, free RockSim training every week. This is what we're doing right now, RockSim Live. And if you click on this, it will take you to our archives and it'll tell you what we've talked about in previous episodes. We are on episode number 121 today, and today is May the 19th, 2023. Once we're done with the episode, we'll put it here on this page, and it will have all the topics and then links to the video, the YouTube video. They're timestamps. So you just click on those timestamps and it'll take you right to those topics. We have Carlos here that says the audio seems on, and Rosa says hello Tim. Thank you both for being here. I do have a couple of questions that came in via email. I got some monitors over here. The first one is from Carlos. And he says, a heavier rocket will fall faster with the same recovery device. Right. In other words, there is an acceleration, deceleration calculations are being done by RockSim. If we create new recovery devices, where can we see the required parameters? Now, this question I am not totally understanding. But let's get into RockSim and see what we can do here. Let's see, let me close all this out. I was playing around. Okay, so here, I'm in, this is RockSim Pro, but it's essentially the same. And let's see, so to get to the recovery devices, we're going to go on the tab that says Rocket Design Components. Just click on that. This rocket has just a streamer in it. And I think he's talking about parachutes, so let's delete this streamer and add a parachute. So really delete this component and let's say yes. So now when you're designing parachutes or using RockSim to pick a parachute, it's best to have the rocket motor inside the rocket because we need the weight of that rocket motor because it's coming down with the rocket. So let's load a rocket motor in here. So to load a motor, we'll go to Prepare for Launch. And it shows you the back end of the rocket, and it's looking for a motor. And it's a 29mm tube that the engine mount goes into. And then you can come down here and choose engine, or you can just double click on that row, and it'll bring up an engine list. And what I typically choose is probably like the biggest motor that I plan on flying into the rocket. So let's go with, I don't attack F-52 or an F-50. What I'm looking for is something that has a lot of total impulse. So the F-52 has 72 Newton seconds of total impulse. That kind of gives me genuinely the weight follows the total impulse. So the more total impulse, the heavier the motor is going to be. And I want to put a heavy rocket engine back here. So I'll click OK on that, and it loaded it into the rocket, and you can see that. And I'm just going to click OK for now. So now we have our motor loaded. So now we're going to add a parachute. So we have to decide where this parachute is going to go. It can either go into this tube right here or this tube right here. Will you let me select that tube? That tube. I'll probably put it into this front tube. So then once we have the tube where it's going to go, then we go up here and we're going to select a parachute. So we're going to select a parachute, click on that, and it gives us a choice of a number of parachutes. And I'm going to cancel, this is the database, I'm going to cancel out of the database, and I'm going to kind of create it on the fly so you can kind of see what's going on here. Alright, so right now, make this bigger. It's showing me the calculated descent mass of this rocket is 131.902 grams. You can see my units over here. But if I come down here to the rocket, it shows 168 grams. Well, how does that happen? How come the descent mass is lower than the actual mass here of the rocket? And the reason is because RockSim has taken out the propellant. Because after the rocket burns the propellant, that weight is no longer in the motor. And so when the rocket comes down, it's going to be lighter than the entire liftoff weight of the rocket. So this here is the liftoff weight, and up here is the descent rate. And that's why I wanted to load a motor in there, because I wanted to account for the mass of the casing, but RockSim is smart enough to know to remove the propellant. It's already been burned. Okay, so now so our parachute is right here, little P, and let me move that back, and you can move that here on this location. And I'm just going to grab the slider and move it back. And now I need to select the material. And so I'm going to select, some 4-ounce ripstop nylon, and I got to give it a thickness, and I'll give it, 2 mil, 0.002, and you can see it hasn't calculated a mass yet. So the shout drawing material, I'll go around for braided nylon, 1/16 inch braided nylon, click there, OK, and it still hasn't calculated a mass. That's what I'm looking for. This is the mass of the parachute, and the reason is we don't have a diameter yet. So as soon as we change the diameter, now we're getting a mass. Here's the mass right here, 1.6 grams. And so if I make this larger, let's make it like a 15-inch parachute. Now we get a mass of 12.8 grams. So there's the parachute. And so what Carlos's question might be is, how fast is this rocket coming down with this parachute? And you can see right here the descent rate. And RockSim is calculating that at 12.8 miles per hour. And if you want to change it to feet per second, you can just go here. So that's 18 feet per second is the descent rate of that parachute. So and if I increase the diameter, you'll see, watch the descent rate here as I make this parachute larger. So as the diameter goes up, the descent rate comes down. So the parachute's getting bigger, and so the rocket is just falling slower as the parachute gets bigger. So that's what we need to know, and that's, I think, is what's behind this question. So now as a designer, here's the hard part, is you have to decide how fast you want your rocket to fall. And this is the kind of nebulous thing, and it really depends on how much speed your rocket can hit the ground without breaking. So if your rocket is built strong like a tank, it could fall like a rock and not break. So if you want it to fall fast, small parachute. But if you got a delicate rocket, you don't want it to fall fast because you're going to just start snapping fins off of it. So what speed do you want? And this is the question that I can't answer. And it really takes experimentation. But here we've got some preset rates in RockSim right here. We have a low descent rate, a medium descent rate, and a high descent rate. So if you're unsure, just choose the medium. So when you click on this, it's going to find the descent rate and it's going to adjust the diameter. So if I click on medium, it changes the diameter to 23 and I get a descent rate of 13.123 feet per second. If I have a high descent rate, now I'm getting to 14.76 feet per second. And a low descent rate is 11.4 feet per second. So there's not a lot of difference in there, but you can kind of see it goes from 11 to about 14 feet per second. So that's not a big range, and that kind of brackets what you want for descent speed. So now on this rocket, this is the Aspire, and it's a minimum diameter rocket. So this rocket is going to go really high. And because it goes really high, even at a high descent rate of 14.76 feet per second, it's going to drift a long way. So every second it's going to come down 14.76 feet. So in approximately 2 seconds it's only going to drop 30 feet. So when you have a wind blowing, it's going to blow it pretty far. The one thing that I didn't set on here is the shroud line length, and I usually make my shroud lengths the same as the diameter. Okay, just like that. And you can see it adjusted the mass. And if I hit the high descent rate again, it just tweaks the diameter just ever so slightly because the mass changed. So that is how I use RockSim to select a parachute. It depends on the weight of the rocket, the descent weight, and then how fast you want it to come down, and then RockSim does everything else. Like I said, the hard part is knowing how fast your rocket can hit the ground without breaking. Either breaking itself or breaking somebody on the ground. You don't want to bonk somebody on the head, because that could be bad. Carlos says, I am drinking chicory coffee here in Marietta, Georgia. How about the rest of you? I'm drinking some tea right here. Carlos's other question, are there graphs or data that we can review during an analysis? Not really. Again, when you're designing or selecting a parachute, you have to decide how fast you want the rocket to fall. And then once you know that number, if I wanted a descent rate of, 19 feet per second, so I'd type in 19, hit the tab key, you can see it already adjusted the diameter for me. It was that quick, that simple. So select the speed somewhere between 11 and 18 feet per second. And that's a good rough rule of thumb type of thing. It's not set in stone because it really depends on your rocket that you're designing. Okay, so hopefully that helped, Carlos. So let me delete that one. And then I got another question from Michael Davis. And he says, I have a couple questions about loading motors into RockSim for you today. I was trying to load some Airtech motors into RockSim. Files were sourced from Thrust Curve, but they wouldn't show up in the choose a motor window. Discovered the files that wouldn't load had an extension of .eng. They were listed as RAS files on Thrust Curve, and no .rse files were listed for these motors. Can I change the file extension, and if so, how? And then he gives an example of two motors, they're brand new Aerotech E24C and the F67C. And so I can almost guarantee you these are not in RockSim. I'm going to cancel that, save my changes. Well, I better save my changes. Yeah, because we took the last streamer out. So here is the Apogee website. I hate when it does that. If you go to the home page, and these are brand new, they just came out this week. So if I scroll here this side, we have an F67 and an E24. And so these are the new motors, and these are 29 millimeter single-use motors. They're both single-use, and they're classic propellant. And so I know these aren't in RockSim because they're brand new today. I actually wanted to keep that open. So let's download and show you how to install those. So I'm going to go to a website called thrustcurve.org. Thrustcurve.org, and hopefully it's working. Okay, so this is his website, and we want the E24 motor, so I'm just using the search bar and hit enter. And it shows an E24C, and it gives you all the parameters here. Here's the thrust curve, and he's got a RAS format, and I'm going to download that file. And where did it put it? Let's see more. It's in my downloads folder, wherever that is. Okay, so there it is, right there. And then the other one was the, if I go back here, F67, hit enter. Okay, there's two F67s. There's a white propellant, and then this F67C, which is the classic propellant. So this is the new one here. So that's the one I'm going to select. And again, if I scroll down on this page, there's the thrust curve, and it's in RAS format, so I'm going to download that. And that one downloaded it as well. Okay, so it downloaded the motors. They're both in .eng format. So let's close that out, and let's go to RockSim. And so there, where did it put it? So they're in my downloads folder, which is somewhere here. Here's the two motors. So to load those motors, you go to File, Import, and then you go to Engine Files. And now I got to find my downloads folder where they're stored. And there they are, F67 and the E24. Let's see if I can get them both. Select them, and I can choose either .eng or RSE. RockSim doesn't care, so it should load both of them. So to answer your question, can you change a .eng to a .rse? And the answer is no. Just changing it, like, changing the file name, it's going to, because the ENG format, they're different formats. One is a text format, the ENG, and the other format, .rse, is an XML format. So they're, which means that they're both text files, but they're formatted differently. So you can't just change the name, but RockSim doesn't care. You should be able to load either one. So if I select open, and it tells me two were copied, and what it did, it took them from the downloads folder and then it put it into this folder right there. And it just copied them. So I think they're still in the downloads folder, but it copied them to the correct data location where RockSim is looking. So then you hit OK, and then it brings up this screen, and I can see the two motors right here, the Aerotech E24 and the F67. So I'm going to select that one, and to use it in RockSim, you have to move it from the left side or to the right side. So you just select it, and then hit Add. And I can hit the next one and hit Add. And so at this point, they should be in there. I got to turn off my phone. And there we go. So now I should see them in RockSim. So let's see if we can find them. So I moved them into RockSim, and so now we'll go to Load Engines. So again, we're going to go Prepare for Launch, this button right up here. This is kind of like the bottom of the rocket with two arrows pointing down to the launch pad. That's what that button means, Prepare for Launch. So click on that, and again we're going to choose engine, and now we're looking, I'm going to sort by engine code. So I'm going to click on the sort here, and it's sorted from highest to lowest, or largest to smallest. If I hit it again, it goes from smallest to largest. And if I scroll up, there is the Aerotech E24 Classic. And then if I scroll down, we're looking for the F67 Classic. Okay, so here it is, the F67 Classic, and here's the other one that's already in the database, F67W. Notice that the name is different because in the file that I downloaded, instead of calling it Aerotech, it just says AT, which stands for Aerotech. That's because people, when they make files, they don't make them the way I would make them. So here's the F67, and if I click, I can select the motor. I better select a long motor delay here. Engine overhang a ½ inch. I click OK here, and under flight events, eject the parachute at maximum ejection delay. Starting state. This is RockSim Pro, so we got more features in RockSim Pro than RockSim. But we're on a 36-inch launch rod. It's aimed. This is kind of like your direction, and I'm going to aim it, 17.6 degrees from vertical, so it's angled a little bit. And then azimuth angle is like a compass direction. North is up here at 0 degrees, 90 is east. If you go south, aiming it south would be like around 180, and then if you're directly west, it's or minus 90 or 270. Either or would work. So if I typed in 270 here, hit tab, you can see, 91.9998. How did that happen? 270. Interesting. All right, and then under launch conditions, this is kind of like my starting location, my latitude and longitude. I'm at an altitude of 1,258 feet. I'm not sure where this is, but if I launch, if I hit flight profile, it should show me a picture of this rocket launching, and it's loading it right now, so I'm going to take a sip of water. Alright, so there's the rocket. Excuse me. The rocket sitting on the pad. I'm going to zoom out a little bit and see where I'm located. I'm in a nice field somewhere. Here's a compass down here. I'm going to rotate it around. I think this is the one that, this is the one we used last week? I'm just trying to figure out, this is in, what state are we in? Here's Alabama, so we must be in Georgia. I think this is kind of near where Carlos is. So that's where the rocket is, and if you lose your place, you just come here and click on the home, and it will fly back home and get to where we were before. And then if we launch it, you can see that I can already tell this is going to be in the air 160 seconds. So that's, 120 is 2 minutes. like 2 and almost 3 minutes. So there it is. It shot off in the sky. It took off really fast. It's coasting upwards, and we're at an altitude of 3,200 feet. And we're getting near Apogee. We're at Apogee. Rocket's coming over the top. And there's the parachute. There's the parachute popped out. You know, our parachute. And now it's going to take forever to get down to the ground. So I'm going to pause it. Let me see this. I'm going to turn on some display information here. So I want to show the trajectory. Let's make it green because it's a little easier to see when it's green. And I don't need to see this. And I click OK. Alright, so here it goes again. You see this green trajectory line here. That's our path, the rocket in the sky. And I'm going to zoom out a little bit so I can get a better perspective of where this rocket's going. You can see our launch pad was way down here, and the rocket's arcing over right now, and the parachute is out because I can see that here. So there's the rocket, and this blue line right there is the shroud line going up to the parachute. And if I grab the slider, I can see where the rocket's going to land, and it's going to land right there. I stayed within the field, right there. But it took, you know, a long time, 160.74 seconds to get back down to the ground. So that was the trajectory. Launched from right there by these trees, went really high, arced over a little bit, and then the parachute popped out here, and then it just drifted nice and softly down to the ground. So hopefully, Michael, that answers your question about how do you add new motors into RockSim. I don't know, it took me longer to describe it than it actually does clicking the buttons. You download the files, you go to File, Import, Engine Files, and then from there you find them, and then you select them and you say Open. But I'm not going to do that again because what it would do is it would put more data in my data folder and I don't want it. And then if I click cancel, it says no files were imported, which is what I wanted. I think I can also come up here to reload engine data, and it will bring up that screen again. And that gets to his second question. He says, I have several motor files under the Available Motor Files tab on the RockSim engine data selection screen that I don't need, but I haven't found a way to delete them. How do I delete them? So here's what I do. Like all these motors over here, I don't want to show up in my data folder, in my RockSim file. Because I never use them. These are hard to get. Like Klima is made in Germany, so they never make it over here to the United States. So by default, everything is over here. And so if I go to my motor file now, and if I go to Prepare for Launch, and I go Choose Engine, you can see now I got all these Cesaroni motors, Aerotech motors, Sky Ripper, Animal. There's a whole bunch in here, and it just, you know, clogs things up, and I understand. So to get rid of them, hit cancel here, cancel here. Go back up here to File, Reload Engine Data, and then take the ones you don't want, like I don't want Sky Ripper, remove. I'll leave Quest, but I don't need Loki, so I'll remove that one. Klima, I'll remove. Hypertech, remove. Gorilla, remove. Contrail, remove. Animal, remove. Okay, so now it's these motors are in my database. But now the second question is, what would happen if you wanted to remove specific Aerotech motors? And that's where it gets harder. So at this point, so for example, if I go choose engine, and I didn't want this engine, so how would I remove that engine? So that one's, this process is a little harder. Because the Aerotech motor, we're storing, you know, a file of hundreds of motors all under the Aerotech brand name. So if I want to lose just one motor, I've got to go into the Aerotech engine data file and remove it. So how would you do that if you really wanted to? Okay, so let me go. What I'm looking for is a program called Engine Edit. And it comes bundled with RockSim. So if you can't find it, if you don't have a desktop icon like I do, I've got Engine Edit and Engine Edit Pro, which are basically the same. One's for RockSim, one's for RockSim Pro, but they're identical programs because they do exactly the same thing. Let me do Engine Edit Pro just because I'm in RockSim Pro. And if I go to File, Open, and now it's looking in the RockSim Pro database folder. So here, if I was in RockSim, instead of being in the RockSim Pro 3, I would be in the RockSim _1. So it's just where the motors are stored. But I want to, I'm in RockSim Pro 3, so I would go to the data folder, and then here's the Aerotech file. You can see the size of it is much bigger than these other ones. Let me make this bigger here. So here's the new motors that I just downloaded right here, the E24 and the F67. The file on these things is 1 kilobyte. They're just like really tiny. This one here, because it's 477 kilobytes, which is still not a big number, but it's 477 times bigger than just one, so that tells me that there's a lot more motor files in here. So if I open that, and you can see it's going to open ENG or RSE. So if I click open, so this is what Engine Edit looks like. And you can see, it's very hard to see this graph here because I got, my settings are, the line is in white. But if I go here, color and font, and normal line color, if I make this red, and I'm going to make the selected points, I don't know, blue, and a normal point color is purple. Okay, so that's what that's going to look like, and then we'll close out of that. It should have took it. What happened? I bet you there's a button down here at the bottom that I'm not seeing. Yeah, there it is. I hit cancel instead of OK. Normal point color, red. Selected point color, what did I say, blue. And normal line color, it's red. This new normal point color, purple. And then click OK. So now you can see the thrust curve. And you can see that this is up here, all the motor files that are stored in the Aerotech one. So if I wanted to delete a specific motor, what I would do is I would find it in the list and then hit delete the selected engine. And I'm not going to do this because I don't want to delete it out of my file, but if you wanted to do it, you could. So you'd hit the delete button, and then you go to File, Save. And so basically it just overrides it. And then when you go back into RockSim, I believe you might have to do reload engine data to make it work. That's if it doesn't automatically work. It shouldn't find it because that file is no longer in that folder. Because once you delete it, it's gone. It'll be gone forever. So be careful what you delete. So hopefully, Michael, that answers your question. Carlos K. says, thanks, your shoot example was perfect. Imagine a real high flyers drogue shoot. And somebody on my staff wrote, he possibly had his filters turned on. I'm talking about the ENG versus the RSE, since ENG files are missing from some of the data that the filters use, and I'm not sure. Yeah. Chris's Rocketry More says, hello, I made it. Almost forgot. Chris, where were you? Fatbank says, if I upgrade to RockSim Pro, what will happen to my existing launch visualizer account? Okay, so Fatbank, they are completely separate. So you will have a RockSim Pro and you will have a launch visualizer. And they are completely separate. So you would probably be billed twice a month, one for RockSim Pro and one for the launch visualizer. RockSim Pro does everything the launch visualizer does. So if you are in doubt on which way to go, get RockSim Pro. The problem is, if you're on the launch field out in the middle of nowhere, then you might want the launch visualizer, because that's in the cloud. So you can run your simulations in the cloud on the field. Where in RockSim Pro, like I was doing, to see the trajectory, that three-dimensional space, you can't do that on the field because it needs an internet connection. So unless your computer is hooked up to the internet somehow, you wouldn't be able to do that. But on the field, you could take out your cell phone and you have, just even cellular data can run the simulations and you can see them in the 3D visualizer. But they are separate. And so you would get, if you had them both, you'd be getting 2 bills from Apogee per month. But if you want to avoid it, I would kind of lean towards RockSim Pro. Basically, the difference is in the launch visualizer, you're only running simulations. You can't design a rocket in the launch visualizer. It's just too complex for right now. We don't have that features. So hopefully that answers that question. Terry Wheelock says, tie a rocket to your finger so you don't forget. I'm not sure what he's saying, but I guess so. Roberto T. says, hello, Mr. Rocket. I'd like to thank you by founding these great enterprise. By founding this great enterprise. I got my level 1 TRA certification last Saturday in Mexico with a Zephyr rocket. How awesome is that in Mexico? Your advice and tutorials were important to my success. You'll launch it many times to experiment and to get experience for a level 2 certification. Thanks again. Great products and inspiring leader. Thank you, Roberto. I really appreciate that. And then Mark Sell says, congratulations, Roberto. And Alfred Indy says, congrats, Roberto. Cool. And that's all the questions that I am seeing right now in the chat. So, if you have a question, go ahead and put it in there right now. Because I don't have anything to talk about. Because this is all about your questions. Tick, tick, tick. I'm waiting. Let me take a sip of water. Okay, no questions right now. Let's see what we can play with. Let's see. What have my programmers been working on recently? I think I showed this one a couple weeks ago under the Flight Simulations tab. This is your summary screen. I think if you right-click on this, on the column header anywhere, and hit Organize Columns, you will see things that you can display. And I think these last two ones are new. The static margin at launch and the manufacturer, I think. I know the manufacturer one is new. So what that does is when you add those, they will show up here as new columns. So this is things that we're going to be adding into the future. This is not in your current RockSim or RockSim Pro. It's something that we're working on, so you're getting kind of a sneak peek at some of the things that we're doing. Do I dare show you some of the other cool things? We got a question. Garrett Fowler says, where can you find Kevlar? And the answer, Garrett, is, well, the internet. So if I go to ApogeeRockets.com, and if I come here to the search bar and you just type in Kevlar, and you can see there's some listings for Kevlar here. So if I wanted 100 pound, I can just click on that. But you can see there's different types here. We got 1,500 pound, 300 pound, 100 pound, which is this one right here, to kind of gauge the thickness. Here's Kevlar thread, and then here's cotton thread for like a shroud line. So it kind of gives you a perspective on how big these are. But if you wanted to find more sizes, you just come down here. So here's Kevlar cord, 100 pound, 1,500 pound, 300 pound, Kevlar thread, and we have nylon tubular webbing. So that's a good place to find it, to get started. And like I said, there's other places on the internet that have it as well. We're not the only one, but they're my favorite one. Okay, so let's see, what do we got here? What do we got? I see things moving over here, but it's actually my screen. Carlos K, could we have a RockSim newbie day on some week? I was stumped for hours once until I understood overhang. Okay, so what is overhang? This is every day is newbie day. We don't have an advanced day. We're all newbies. So overhang is how far the engine hangs out the back of the rocket. So let me go 3D so you can see this a little bit better. So here's the rocket, and if I zoom in, if I hit shift and drag the rocket, you can see what I'm doing. So you see that the rocket engine is hanging out the back. This is called the overhang. How far it overhangs the back of the engine mount tube. And it's not the rocket, it's the engine mount tube, because they could be different. This rocket happens to have the rocket diameter also is the engine mount. So that overhang here is how far it sticks out. And to adjust that, you go here to prepare for launch. Let me slide this up here so you can kind of see this image on the back here. And the overhang is right here, this column. So you can type it in here, like if I make it 1 inch and hit tab, you can see now the engine is hanging out 1 inch. And if you don't want it to hang out at all, you can make it 0. You can actually make it a negative number if you want. So if you want it recessed up into the rocket, you have to hit negative, I don't know, minus 0.5 and click OK. I can't see it from this angle, but if I click OK here and then rotate this around, you can see that now the engine overhang is a negative number. Now normally you wouldn't have it recessed into the tube. Sometimes you could, and there might be a good reason for it. For example, if your rocket was unstable, and an unstable rocket means that the center of gravity is behind the center of pressure. And if I move, the engine is heavy, so if I move the engine forward, that's going to take this center of gravity and it's going to move it forward. So if the center of gravity before was right here, with the engine hanging out a half of an inch, if I slide it forward, it's going to move the center of gravity forward, and I might get it in front of the center of pressure, and that would make the rocket stable. So there are situations where you might want to do it. Normally you wouldn't, because now you have the flame of the rocket on the inside of the rocket, inside of the tube, and it has two undesirable effects by doing it inside the tube. One is you got that heat and it radiates outward from the plume, and you're going to scorch the inside of that tube. And you might even set it on fire, depending on how far up inside the tube it is. And the second reason, and RockSim doesn't take this into account, but there's a phenomena called the Krushneric effect. And the Krushneric effect is, if the flame is going through the tube, you might not get optimal expansion of the flame, because in a rocket motor, you're creating a venturi. You got the if you cut a nozzle in half, you have the converging section of the nozzle where the propellant's over here and it gets smaller, and that squeezes the gases, and so they go really fast until they get to the nozzle throat, which is the smallest point in the rocket nozzle, and that's called the choke point. And what you want is that what happens is at the smallest point, the velocity of the gases is Mach 1. You can't get it any faster than that doing a diverging, but you can get it going faster if you have not a converging, a diverging, so it's getting bigger. So as it goes through the choke point, it gets to Mach 1, and then the nozzle gets bigger, and the speed of the gases becomes faster, and that's what you want. But if you have it recessed inside of a tube, it messes that up. And so now, instead of increasing the speed as it's coming out of the nozzle, now you're actually decreasing the speed, and so you're losing thrust. And so the Krushneric effect is you lose thrust if you recess the motor inside of the tube of the rocket, like we're showing here. And recessing it a little bit is okay, but I think the general rule of thumb is you don't want it recessed more than one diameter of the rocket casing. So this is a 29 millimeter diameter casing right there. So I don't want this to be greater than 29 millimeters, which is just a little over an inch. So in general, don't recess the motor unless you need it for your center of gravity, to move the center of gravity forward to make the rocket stable. Roberto T says, hi, again me, question, can I use other thing, example balloon, for replace a parachute in RockSim? And the answer is yes. We talked about this maybe about a month ago. Carlos asked this question, so let me go back to the Apogee website because it's a really long and convoluted answer. So if I go back to the home page, and if I scroll down to the RockSim Live training, and I want to search on this page specifically for the word balloon. So I don't want to use the search bar because this will search the entire website. But if I do a Control F, you see it brings up a little finder window, and it's going to only search this specific page. So if I type in balloon, okay, so I started typing in ball, and it found it. It says simulating a balloon rocket in RockSim. So if you're interested in swapping out a balloon or a balloon for a parachute, I would start there. I thought we talked about it twice, but I think that was on April 17th, so that was just a little over a month ago. Let me type in helium. No, helium doesn't show up, because what we were talking about was instead of putting in just a regular balloon, how about a helium balloon? And we did talk about that. I think it was on that one episode on April 7th, is what I said? March 31st, the balloon rocket. It's possible. It basically what we had to do was to create a new material, and that material represented, you know, here's a material, but we changed the parameters. We kind of did a sleight of hand, and in the database we made the weight of this material a negative number, so it was lighter than air, and so it would float, even though the shape was like that, and it would fall like a rock. So we could simulate the balloon, but it wouldn't look like a balloon. It would still look like a parachute. So, yeah, that's a really good question, though. And we had a lot of fun playing with that. I think we took a long time talking about that. Okay, no other questions? And Terry says, yes, every day is newbie day. Cool, no more questions. You can still ask your questions. What else am I working on? We got a couple of new rockets coming out, and one of them is called the Kestrel. Let's see if it shows up. I don't think it's going to show up. Oops, that's not the search bar. This is the search bar for the entire website. It doesn't show up yet because it's not turned on. It's on. I know it's on the website because I was working on the page, but we have a little checkbox that says make it live, and it's obviously not live. And North Coast Rocketry is also releasing a rocket called the Javelin. And here's the Argo D4 Javelin. And it's not live either. North Coast Rocketry. Oh, there's the Javelin. Although this is a different version of the Javelin. Ours is the one, the new one. He has a big version and a small one. That's the big one. I'm giving Matt some. Oh, here's the new one. Look at that. He's got it on his webpage. Can I see that picture? That's about how big it is. I can't get a bigger picture of it. I can't click on it. Yeah, so that's coming out. We have it here at Apogee, but we're not allowed to start selling it until Wednesday of next week. But it looks like Matt is already selling it on his web. Oh, ships May 24th. Okay, so the same day. That's cool. So we'll have that next week. Another new product we're working on that should be available pretty soon is a new version of the simple timer. And this is on our website right now. It has a new version. What a timer does is an electronic device that allows you to do staging. So this was a two-stage rocket. You can see that the booster was here and the sustainer is here. And you can see that this cloud of smoke starts way up in the sky. So this is called an air start. And so, you know, typically on an Estes motor, the two motors are butted back to back. And when they stage, the bottom motor ignites the top stage. But if you want to air start, or if the motors are separated at all, you need a separate ignition system in the upper stage to ignite the upper stage motor. And that's what a timer does. So like this one is separated. You can see the engine would probably be right here. Ooh, what the heck is going on there? And then the upper stage is right there. And then here's another example of an air start where the upper stage motor started burning right there and then took off. In this one you can see where the motor is burning, and then here's where it's coasting. You can definitely see the different color smokes. And what the timer does is there's a special safety feature built into the timer, is that in order for the upper stage to ignite, the rocket has to be pointed up within 45 degrees of vertical. So if the rocket was aimed sideways, we don't want to ignite it then, because then it's going to go off to the side. And so the timer would prohibit the motor from firing. And so that's always been a feature of the timer, but one of the new features of the timer is now it has an Apogee deployment charge in it. So if the rocket was unsafe and it was going this way, that upper stage wouldn't ignite. But now, how do you control the ejection charge of that upper stage? And so the new version of the timer has an Apogee deployment charge. So if it goes sideways, it detects the Apogee point and it will fire off an ejection charge to push the parachute out, so that that top part, even though it started out as unsafe, now all of a sudden becomes safe because it's coming down nice and slow. So that's a new feature in the new version of the timer. And this should be out. We have them in stock right now, but we don't have the instructions completely done. So we're working on to get those instructions done. But one of the things that we discovered about having that Apogee charge in there is we call it the quick stop recovery system. And it's an actual added safety feature, because what would happen if your rocket went unstable? And as soon as it goes unstable, it detects Apogee and it will fire off that parachute right away. So it just kind of like the rocket takes off and goes unstable, and it would stop it midair. And this actually happened to us when we were test flying the rocket. We were actually test flying this rocket right here. When we launched it the first time, we launched it as a two-stage rocket, and everything worked just fine. The rocket, in fact, this picture is right here, is the rocket staging. So, and the rocket, once it's staged, it went really high, went nice and straight. But when we launched it the second time, we only launched just the upper stage, not the booster stage. And what we did was we put in a motor that was going to eject at a really long delay. So it was a small motor, it was a C12, and I think we chose a 7-second delay, so that the rocket would come over the top. It would be coming down when the parachute deployed. But we wanted to test the apogee feature, so when it got to the top, it would sense the top and deploy. And if it didn't deploy, well, as it started coming down, the motor's ejection charge would fire off. So it was still a safe launch. It's just a really long delay. But what happened was the rocket came off the pad, and immediately, as soon as it cleared the rod, it started going unstable. And when the timer detected that it hit apogee by going horizontal, it said, "Hey, I'm at my apogee," and it fired off. And the rocket was maybe made a peak altitude of 20 feet. It was not high at all, and it worked. And in fact, this is better than a regular dual deployment altimeter, because on a dual deployment altimeter, there's a feature. They all use a barometric sensor to detect how high the rocket is. So in a barometric sensor, as you go up, the pressure is getting lower, and when it reaches the peak altitude and then starts coming back down again, now the pressure is increasing. And when the altimeter sees that the pressure is increasing, it says, "I've reached apogee," and it deploys the parachute. But it has, barosensors can be tricked by a gust of wind, because if the rocket's sitting on the pad and a gust of wind comes along, that gust of wind acts like the pressure is increasing. So the altimeter, when the wind comes along, thinks that the rocket has already reached its apogee and starting to come down. And you can't have that while it's sitting on the pad. So in a normal altimeter, the altimeter has to sense a minimum altitude increase. So the pressure has to go down before it comes back up. And that pressure is typically around 60 to 80 feet. And since our rocket never got that high, a regular altimeter would not have triggered. And so it wouldn't have been a safe recovery. The rocket would have just continued to do this, spin around, maybe hurt somebody. And so we really liked that feature, and we call it the quick stop recovery system. So if you think your rocket might be unstable, I would throw in a timer, this simple timer, because it's going to detect it going unstable and it's going to kick out the parachute. Another time you might want to use it is if you have a rocket that needs a really short delay. So rockets that are really high drag, like a spool rocket or a pyramid-shaped rocket, things that are really high drag, those things need really short delays. But the problem is you typically can't find a delay that's short enough. So this is where another reason that you would use that apogee ejection charge. And then also for plugged motors. Aerotech makes some plugged motors like the G8, the G12, and the H12. And these are only available in plugged motor versions. So how do you eject a parachute when you have no ejection charge in the motor? Well, you'd have to use either a timer like this one that has the apogee charge, or a regular dual deployment altimeter. Either one will work. This one just triggers a lot faster. It detects launch a lot faster. Somebody is asking, Roberto, is how are you going to fit a balloon into the airframe? And I think the answer to that is you're going to blow it up later. Okay, so what time is it? Oh, we're at 3:05 p.m. So we've gone actually an hour already. So we are at a good stopping point. I didn't get a lot of questions this time. So bring your RockSim questions. Even if we've answered them before, I'll either point you in the right direction or we'll actually go through them. The question about the balloon parachute, that's a long question, and that's why I kind of referred you to a previous episode. But the question about engine overhang, that's a simple one, so I can answer that one really quick. And every day around here is newbie day, so if you have a newbie question, don't be afraid to ask. We're all newbies. I'm always learning myself, and I use RockSim to help me. We have HNX Media. He says, "Thanks, Tim. Solid information in this live stream." Thank you, HNX Media. I appreciate that. And Carlos says, "I also like Tim's Tech Talk today." Cool. Next week is Friday. I'm pretty sure we're going to be here. Next weekend is Memorial Day weekend. So I know a lot of you might be traveling around, but I'm going to the National Sport Launch, and I'm not sure exactly which days I'm going to be there. For us, the National Sport Launch is here in Colorado. It's still, for me, a 3-hour drive down to the south part of the state. It's south central Colorado, so if you find the middle of Colorado is a square, one of the square states. So if you find the middle vertically, then come all the way down almost to the bottom to where New Mexico, that's where the National Sport Launch is going to be. It's in Alamosa, Colorado. It's in a high valley, so it's perfectly flat, but you have mountains on both sides, which is really cool. So no matter which way you look, you got a mountain panorama, but even though it's just flat, it's one of the big valleys. They grow a lot of potatoes there. It's also close to the Great National Sand Dunes, which is a national park, the highest sand dunes in North America. I think they're over 700 feet high. They're good for skiing. Although you don't ski very fast going through sand, but you can bring your skis, you can bring a sled, not the kind with the runners on it, but something with a flat bottom, or even a sheet of cardboard. You see people all the time sliding down the hills on sheets of cardboard. It's a great place to look. Okay, so we are going to end this live stream. Like I said, I think we're going to be here. So tune in anyway. And we'll go ahead and end this broadcast by saying 5, 4,